In this video, we discuss learning outcome number 5 from lesson 4.1, which is all about odds and their relation to probabilities. So both odds and probabilities are ways to measure likelihood. They're just a little different. Odds are more difficult to compute than probabilities, so they appear in different contexts. The reason that sometimes odds are used as an expression of likelihood is that they make it easier to deal with the money transfers that are associated with gambling. So we're going to talk about the odds against something happening, the odds in favor of something happening, and we're also going to talk about payoff odds. If you ever go to the casino, or if you choose to play the lottery, or if you were to go to a racetrack, they're going to talk about odds. If you ever choose to do that, it's important to understand what those numbers mean. So we're going to talk about what those numbers mean in this lesson. Now, probability is another expression of likelihood, which is relatively easy to compute, as we've seen. Mathematicians use probabilities, statisticians use probabilities, and anytime statistics is used in research, and it often is in the social sciences, you're going to see probabilities. But since we live in Oklahoma and we've got a lot of casinos around here, it's a good idea to understand odds. I love this picture that I found online. I'm sure you've seen it many times, or at least you used to see it when the movie was popular and it came out. It says, "May the odds be ever in your favor." That is my wish for you, but hopefully I don't come across the way this poor character does. But yeah, let's make sure we understand what it means for odds to be in our favor by understanding the definition of odds in favor of some event happening. So here are a few definitions. These next few slides deal with actual odds against something happening and actual odds in favor of something happening. Both of these are measures of likelihoods of events. Actual odds against event A occurring are just given by a ratio. We take the probability that A doesn't happen and we divide it by the probability that A does happen. It's usually expressed as a ratio like this. So we've got the ratio of A to B, or sometimes we'll read it A to B, where A and B are integers. Now we tend to reduce that if A happened to be 16 and B happened to be 4, rather than saying that we've got actual odds against event A occurring as 16 to 4, we'd simplify, and 16 divided by 4 is 4. So rather than saying 16 to 4, we would express the actual odds against A happening as 4 to 1, because 16 divided by 4 is 4. Now the actual odds in favor of something happening are the reciprocal of the odds that we were looking at on the last slide. So you might think this looks exactly the same as the actual odds against something happening. The formula, you might say, what? How is that different from what we just did? Oops. Look at this, look at it very carefully. The actual odds against A occurring have the probability that A does not occur in the numerator. When we talk about the actual odds in favor of A occurring, the probability that A does occur is in the numerator. So basically you just take that fraction from the last slide and you flip it, and that gives you the actual odds in favor of A occurring. So if the odds against an event occurring are A to B, the odds in favor of that event occurring are B to A. You just flip them. And the ones in favor of A occurring have the probability of A in the numerator. The odds against A occurring have the probability that A doesn't occur in the numerator. Now, payoff odds are different. These are not expressions of likelihood, but this is just another ratio that a casino would use. These deal with the ratio of the net profit that you would win if you do win to the amount that you bet. So payoff odds against event A are the net profit to the amount bet. So it's just another ratio. I've never actually played roulette, but we've got a roulette wheel here. And I'm told that it has 38 slots. One slot is the 0 slot, and I don't even see it on the picture. There's got to be a 0 around here somewhere. Maybe not. Maybe it's hiding behind that over here. There's a 0 slot. There's also a 0 slot, and the others are numbered 1 through 36. You might place a bet that the outcome is an odd number. if you were to place that kind of bet, we could ask you about the probability of winning. We could ask you about the odds against winning, the odds in favor of winning. We could talk about payoff amounts. That's what we're going to do in this example. Excuse me. So the first question asks us, what's the probability of winning? It's actually pretty simple. We're going to use the classical approach here. You have to just think about the number of ways that you could get an odd number off of that roulette wheel, and then divide by the number of possible outcomes. So that's pretty simple. Now, if you've got numbers between 1 and 36, half of those would be odd. So the number of odd numbers on that roulette wheel would be 18. And then the number of possibilities isn't 36 though. It's those 36 possibilities, plus the possibility that you land in the 0 slot, plus the possibility that you land on the 0, 0 slot. So there are actually 38 possibilities here. So we're going to take 18, the number of ways you can get an odd number, and divide by 38. That's the number of possible outcomes that you have. And you can use a decimal approximation if you like. That is approximately 0.4737. If we want to interpret that, we can move that decimal twice and think about it this way. You basically have a 47% chance of winning. When you talk about getting an odd number when almost half of the numbers on that wheel are odd, but then there's these other 2 slots, the 0 slot and the 0, 0 slot. So it's a little bit less than half. The probability that you end up on one of those is that 18 out of 38, or 0.47, 47%. That is a little bit less than half. So that number makes intuitive sense to me. You always want to check and make sure it makes intuitive sense. If it doesn't, you may have made an arithmetic error. So we're still dealing with the same situation. Now we've got another question. The question says, find the actual odds in favor of winning. So here's our formula. The odds in favor of winning is the ratio, of the probability of winning to the probability of not winning. Now we already found the probability of winning. We know that there are 18 odd numbers out of 38 slots. So the probability of winning, is 18 in 38. The question is, well, what's the probability of not winning? Well, if 18 of those numbers are odd and there are 38 slots, the rest of them would not be odd, and that would lead to not winning. So you can just say, well, if there are 38 slots and 18 lead to winning, I guess 20 must lead to not winning. Or you can use the formula. You're going to get exactly the same amount. You're going to take 1 and subtract that 18 and 38. And that's 38 over 38 minus 18 over 38. Get a common denominator, and then subtract the numerators. That 38 minus 18 would give you 20. Or you can just say, well, if 18 out of 38 are odd, then 20 out of 38 must be not odd. Now we still have to answer this question. We're not done yet. The question says, what are the odds in favor of winning? So we had to compute the probability of winning, which we already did. Then we use the probability of winning to find the probability of not winning, which is this right here. And then you just divide them. Divide them and simplify as much as possible. So you've got 18 out of 38 divided by 20 out of 38. Those 38s in the denominator, if you were to write out the fractions, write out the fraction in the numerator, take the one in the denominator, flip it, and multiply, those 38s will cancel. And what you end up with is 18 out of 20, which simplifies to 9 out of 10. So the actual odds in favor of winning are 9 out of 10. This question asks for the odds against winning. Now remember how odds against winning and odds in favor of winning are related to each other. You just take the reciprocal. The odds against winning are given by this ratio. It's the probability of not winning to the probability of winning. Well, on the last slide, we saw that the odds in favor of winning were 9 out of 10. So the odds against winning must be 10 out of 9, or 10 to 9. I guess I shouldn't say 9 out of 10. Let's say 9 to 10, or 10 to 9. And then this question is asking about payoff odds. Now remember what payoff odds are. It says, if the payoff odds are 1 to 1, how much profit do you make if you make a $20 bet and then win? And then the question says, what if the odds were 2 to 1? Remember what payoff odds are. Payoff odds are this ratio of the net profit to the amount bet. So if the payoff odds are 1-to-1, that means if you bet $20, you would win $20 extra. So basically, if you want to find the net profit, you'll take 1-to-1, that ratio here, you'll write it as a fraction, and then you'll set that equal to the net profit, which we don't know, which I'll call X, to the amount bet, which happened to be 20 in this case. If you cross multiply, you're going to get 20 equals X. So you've got a net profit of $20. So if you paid $20 to play and you won $20, they're going to give you $40 back. So you gave them 20, and then you played, and then they give you 40 if the payoff odds are 1-to-1. Now, if the payoff odds were 2-to-1, what that would mean is that this ratio of 2-to-1 is equal to the net profit divided by that amount bet, which was $20. Again, we just cross multiply. 2 times 20 is 40, and that's equal to 1 times X. So that means X, that's our net profit, is 2 times 20, which is $40. So in this case, you bet $20 and it was a 2-to-1 bet. Payoff odds were 2-to-1. So, and then because you happen to win, you win $40 on top of the $20 that you already spent. So if you gave them $20 and then you win a bet that's 2-to-1 payoff odds, they give you $60 back. You had $40 net profit. Now this last one is a hypothetical. This is very unlikely. This question says, if you could convince a casino to change its payoff odds to match the actual odds against winning, how much would you win? Well, in order to do that, you need to know what the actual odds against winning are, and we calculated that earlier. The odds against winning were 10-to-9. And now we want to take our payoff odds, which are a ratio of net profit to the amount bet, and we want to set that equal to 10-to-9. So 10-to-9 is our ratio, and we want that to be equal to the net profit, which we don't know, divided by the amount that we bet, which was $20. If I solve this equation for X by cross multiplying, I'm going to get 10 times 20 is 200, and 200 equals 9 times X. If I take that 9 times X equals 200 and I divide both sides by 9, I get that X, that's my net profit, is approximately 200, or it's exactly 200 divided by 9, which is approximately $22.22 net profit. So in this case, if the payoff odds were changed to be the actual odds against winning, then the net profit would be $22.22. So if you made a $20 bet and you had a net profit of $22.22, they would give you $42.22 back. So just remember, when you're looking at the odds in favor of winning, or the odds in favor of event A, you've got the probability that A happens divided by the probability that A doesn't happen. When you're looking at the odds against winning, or the odds against A happening, you've got the probability that A doesn't happen in the numerator. So if you hear against, think the probability that A doesn't happen. If you hear in favor, think about the probability that A does happen. And then the other one goes in the denominator. So that's odds for and against, or in favor of event A or against A winning. Or not necessarily winning, but against A in general. And then the payoff odds have nothing to do with this likelihood. It's just another ratio. It's a ratio of the net profit that the institution, usually a casino, promises to give you to the amount that you choose to bet in the first place. So you're risking $20 here. And these payoff odds, are telling you how much you may profit, how much you can profit if you happen to win when you bet that $20. So if you bet $20 and the payoff odds were 10-to-9, then if you happen to win, they would give you $22.22 profit. So I hope that helps you understand odds, and I'll see you in the next video.